we were talking about the slope and how to find it using ordered pairs before break. So we're going to do another one of those now. We'll probably do two of these that have fractions. What we're going to have to do is we're going to have to clear out the fractions. And then we're going to have to work with what's left over and reduce it down. So let's again try to find the slope. So I'm going to give you two ordered pairs, about 4/5, comma 2/3, and 1/3, comma 8/5. So we're going to start with this one here, and this is very similar to a question in your homework. It has fractions. So we're going to go ahead now and work with this one. Now when we work with these fractions, they're no different. We are going to clear them out though. So this is x1, and this is y1, and this is x2 and y2. Now you only have one of these questions in your homework. I'm going to do two examples, just so you know how to work through the one question in your homework. So we're now going to go ahead and rewrite everything. So y1, that's 2/3, minus y2, which is 8/5, over. Down below, we've got 4/5, minus 1/3. Okay, so don't let the fractions intimidate you. We're going to get rid of the fractions in just a moment. Okay, so we got the fractions put in. Now we're going to go ahead and get rid of them. What's the least common denominator now of that 3 and 5? Well, the least common denominator of 3 and 5 would then be what? Would be 15. Okay? So we're going to go ahead and clear out our fractions just like we would any other problem that has fractions in it. Okay, so we found our least common denominator of 15. So I'm going to multiply everything now by a 15. So 15 over 15. We're going to have to distribute it through to each and every part. And if we need to, we can just do them down below and put them all back together. So if we struggle with fractions, we'll just work them out down here. Let's work with our first one. 2/3 times 15 over 1. Well, 2/3 times your 15 over 1. Remember, what do? Divide and multiply. Okay, so 15 divided by 3. 15 divided by 3, that's a what? 15 divided by 3, that's a 5. 5 times 2 makes it then a what? 10. So there's that piece. Then the next one. Minus 8/5. Right? Times that 15 over 1. What do? Divide, multiply. So 15 divided by 5. What's our 15 divided by 5? Okay, 15 divided by 5 is 3. 3 times a negative 8 makes it a negative 24. Right? Divide, multiply. Remember? Divide, multiply. Divide, multiply. If it helps, you can write them over to the side. Or you can just divide and multiply mentally. Either way. Let's do the down below. We've got 4/5. Multiply that again by a 15 over 1. What do? Divide and multiply. 15 divided by 3. 15 divided by 5 here. 15 divided by 5 is 3. 3 times 4 makes it a 12. Next one. What do we have? We have a minus 1/3. Multiply that by a 15 over 1. Well, 15 divided by 3. 15 divided by 3 is a 5. 5 times a negative 1 makes it a negative 5. Now we're almost done. Put the pieces back together. So we've got 10 minus 24 over 12 minus 5. 10 minus 24, that makes it a minus 14. 12 minus 5, okay, 12 minus 5 makes it a minus 7. Sorry, positive 7, if I did the math right there. That's going to be a positive 7. And what do we know now about negative 14 over a positive 7? Negative 14 divided by positive 7, that comes out to be a negative what now? Negative 2. We'll do one more of these. I'm going to make it look very, very similar to that question I gave you in your homework here. I'll just change the numbers a bit. So again, we're going to try to find the slope. And I'm just changing the numbers a bit, but very, very close. And this is going to look very, very similar to question 9. So this is going to be like homework number 9. All right, so what do we have? X1, Y1, X2, Y2. Plug the values in, so we have minus 3/7, minus 0, that's your Y part. And for the X, we've got 5/6 minus 3/2. Okay, so just plug the values in. Now, what am I going to use for my least common denominator? Let's look now first at the 6 and the 7. What's the least common denominator of 6 and 7? Well, 6 and 7 have nothing in common, but 6 times 7, well, that's a 42. So my least common denominator is going to be a 42, because it also goes into that 2, doesn't it? 42 goes into 2, 42 goes into 6, 42 goes into the 7. Now we're going to go ahead and multiply everything by 42 over 42. We can write them out if we need to, or we can just do it mentally, either way. Just so we have it in our notes, I'll go ahead and write them out. So let's look at our first one. Minus 3/7 times 42 over 1. Well, how does that work? Okay, 42 divided by 7. What's 42 divided by 7? 42 divided by 7 is a 6. 6 times a negative 3 makes it a negative 18. We don't have to worry about the 0 because that piece is gone. Down below, we have 5/6 times, again, our 42 over 1. So what do? Divide, multiply. 42 divided by 6. Well, 42 divided by 6 is 7. 7 times 5 makes it then a 35. Next one, what's our last piece going to be? Our last piece is going to be minus 3/2 times 42 over 1. 42 divided by 2, that should be a 21, right? And then 21 times 3 should be a 63. So it should be a negative 63, I believe there. Let me double check and make sure, because 42 divided by 2 is the 21 times that negative 3. That makes it a negative 63. We're going to put our pieces back together. So what do we have for our pieces? We have a minus 18. We don't need to worry about the 0 because that's gone. So we've got the minus 18. And down below we have a 35 minus 63. 35 minus that 63, it's going to be a negative 28. Over negative 18. We can reduce this down because they're both even numbers. And negative makes it a positive. So that's going to be a positive 9 over what? 14. Positive 9 over positive 14. That would be then your final finished answer. So what did we have to do? Just so we can go back and review, this is very, very similar to what you have in your homework for that one question. We went through and we wrote up our formula, filled the pieces in, right? Okay. Then we figured out the least common denominator of 6 and 7 is 42. That's also going to take care of the 2 there. So we multiplied everything by 42. So what does that mean? When we declare our fractions, divide and multiply. So 42 divided by 7 is 6. 6 times that, negative 3. That makes that first piece a negative 18. Zero's gone. We don't have to worry about it. 5, 6. Well, 42 divided by 6, that's a 7. 7 times 5, that makes it then 35. That goes there. Minus 3 halves. Well, 42 divided by 2 is 21 times a negative 3 makes it a minus 63. We put our pieces back together. We subtracted them and we reduced it. The very last part of this section is how to find the equation of a line. How to find the slope given a line equation. So now we're going to learn how to find the slope from an equation. So we're going to be finding the slope from an equation. How we do that is we solve it for y. So step number 1 is going to be solve the equation for y. And that's going to put it then in what's called slope-intercept form. And that's y equals mx plus b. And then that m right there, that is your slope. So we have an equation, and we want to find the slope of that equation. We solve that equation for y. Once we've solved it for y, then the number in front of the x, after you've solved it for y, then that becomes your slope. So you have to solve it for y first. Then, once you've done that, the number in front of the x is your slope. So we'll do a couple of these, and then we'll talk about parallel and perpendicular lines. And then look at a couple of the applications. So let's go ahead and find the slope. How about 4x plus 9y equals negative 5. So we want to find the slope. Okay, so what do we have? Now, when we look at in this section, in this chapter 2, we need to think about what we got and what we want to find. Okay, so what do we have? Well, we currently have an equation. Okay, so we cannot use the point formula like we did a moment ago. We don't have points, we have an equation. Whenever you have an equation, what you generally want to do is you want to start by solving for y. That's going to point you in the right direction. So if we go ahead and take this and we solve it for y, then we can find our slope. So we want to find the slope, so we move that 4x over. We're trying to solve this all for y. So then that becomes 9y equals minus 4x minus 5. Divide everything by the 9. Now we have it in what's called slope-intercept form, where it's y equals now minus 4/9 x minus 5/9. Now we want the slope. And once you have solved it for y, you have to solve it for y first. But once you have solved it for y, then that becomes your slope. So in this case, my slope now is a minus 4/9. So what did I do? I took my equation, right, and I solved it for y. Once it was solved for y, then I took the number in front of the x after it's been solved for y, and that is my slope. So solve it for y, and the number in front of the x becomes your slope. And if there's no number, we know there's a 1, right? If there's no number, it's always a 1 then. So let's try another one. So let's go ahead and find the slope here. How about minus 4y plus 8 equals 3x. Again, what do we need to do? We want to find the slope. What does that entail? We go back up and we look at our directions. We have an equation, right? We want to find the slope. So what do we need to do? We need to solve this equation for y. So I'm going to move that 8 over. And then we've got minus 4y equals 3x minus 8. We're going to divide everything by our negative 4. And reduce down any of the fractions if we need to. So that leaves you now with y equals. We're going to bring this negative up to the top. So that's going to be a minus 3/4 x there. Negative and negative makes it a positive. And 8 divided by 4 is a 2. We want our slope. Next week, we're going to talk about the y-intercept. But today, we're only going to get the slope. And so what's our slope going to be then? Minus 3/4. So we took our equation, solved it for y, and we got our slope. Now, in some cases, it may already be solved for y. So in this case, let's look at this one here. Don't try to make them harder than they need to be. In some cases, you may not have to do anything. If we have an equation, we want to always solve that equation for y, because that's going to point us in the right direction. Well, this one is nice because this one's already been solved for y, hasn't it? Right? So all the work has been done. We don't have to really do anything. We want to find the slope. Has it been solved for y? Yes, it's already been solved for y. That means then, if we want to find our slope, the slope is going to be the number in front of the x after it's been solved for y. So in this case, our slope would be 3. It's already been solved for y. So we really didn't have to do anything. Just find the 3 there, and that's going to be our slope. A lot of times, though, this type of problem is more of a challenge for students because they think you have to do more. No, all you need to do is find the slope, and if it's been solved for y, you don't have to do anything. You just write the number down. We can also look at two lines, and we can discuss the possibility of them being parallel, perpendicular, or neither. So parallel lines, they have the same slope. So parallel lines, they have the same slope. And here's an example. Well, I'll put actually several examples down here. Here's some examples of parallel lines. Y equals 8x plus 9. And y equals 8x minus 10. Why are these parallel? This one has a slope of 8. This one also has a slope of 8. So they would be parallel, right? Parallel lines have the same slope. Another example. Y equals 9x. Y equals 9x minus 13. Slope of 9. Slope of 9, right? When they have the same slope, they are parallel. Now, when we are working with equations, they're not going to be solved for y. We're going to have to do that to get the slope first. So when we look at parallel and perpendicular lines, we have to do a little bit extra. We have to solve it first to get the slopes. But if the slopes are the same, right, then they are parallel. Now, perpendicular lines, perpendicular lines, they have opposite or negative reciprocal slopes. The textbook uses negative, but I think that's confusing for students. So I usually say opposite reciprocal slopes, or opposite sign reciprocal slopes. Okay, so we're looking for the opposite signs reciprocal slopes. Textbook uses negative, but sometimes students get confused when I say that negative. So I usually say opposite, or even more elaborate, opposite sign reciprocal slopes. So here's some examples. These are going to be perpendicular. Y equals minus 2/3 x, and y equals, let's focus on what we're working on right now. Y equals now 3/2 x plus 19. Now, why would these be perpendicular? Well, the first one has a negative 2/3. Let's please focus on what we're working on here. Okay, so what are we looking at? We're looking at these two lines. These two lines are going to be perpendicular. And let's talk about why they're perpendicular. So the slope of my first one, remember that number in front? That's your slope. So minus 2/3. What about the other one? The other one is 3/2. Now, these are going to be perpendicular. Why? They are going to be perpendicular because they have to be opposites in signs. Are they opposite in signs? Is one positive, one negative? Yes. Are they reciprocals, meaning you flip the fraction over? Yes. Okay, so they are opposite in signs and they've been flipped over. Therefore, they are perpendicular. Let's try another example. Here's another example. Y equals minus 5x plus 18, and y equals, and I should put the in there, y equals 1/5 x minus 12. These would be perpendicular because this one has a slope of negative 5. This one has a slope of 1/5. It has to meet those two criteria. They have to be opposites in signs, right? One's positive, one's negative. They are. And then they have to be reciprocal. So what happens if I take 5 and I flip it over? If I flip 5 over, it becomes what now? It becomes 1/5. This would have to be able to be flipped over. So parallel lines have the same slope. Perpendicular lines have opposite sign, reciprocal slope. So they flipped over. One is positive, the other one is negative. Now we're going to look at two lines, and we're going to decide if these are parallel, perpendicular, or neither. So are these lines going to be parallel, perpendicular, or neither? Here's your two equations to work with. So I want to see if these lines are going to be parallel, perpendicular, or neither. Now, these are going to require us to do some algebra. On the examples that I gave you, they were already solved for y, so the work was already done. However, on these, we're going to have to solve each one for y, get the slope, and then compare them. So let's go ahead and do that. I'm going to separate my paper here. I'm going to do each one. I'm going to solve it for y so that I can get my slope. So let's move that 3x over. And I get minus y equals minus 3x plus 18. Now, a commonly made mistake is someone's going to say my slope is a negative 3. Now, that's not correct because I want positive y, not negative y. So divide everything by a negative 1 because that's negative in front. And that leaves you then with y equaling now 3x minus 18. And so my slope would be then 3. Number in front of the x is the slope. Repeat the process on the other side. Move the 12x over. Minus 4y equals minus 12x plus 20. Divide by your negative 4. And y equals now, okay, negative and negative makes it a positive. 12 divided by 4 is a 3x. 20 divided by negative 4 is a negative 5. So my slope is the number in front of the x, which is the 3. These are the same. So these would be parallel. Okay. So since these are the same, that means your answer would be parallel. Is everyone okay with that? Everyone see how that works? So I took them, solved it for y. They were exactly the same, parallel. I'm going to do one example of each one. One parallel, one perpendicular, and one neither. So we'll do two more of these. Okay, the next set we're going to look at, we're going to see if these are parallel, perpendicular, or neither again. How about y minus 9x equals 18. And we'll do, let's see, how about 9y plus x equals 23. Let's make sure that does what I want it to do. Okay, so bring that over. I'll make that. Yep, that'll work. Okay. So let's see if these are going to be parallel, perpendicular, or neither. Again, draw your line. We're going to go ahead and solve this for y. So on our first one, we're going to add 9x to each side. And that leaves me then with y equals 9x plus 18. My slope would be 9. No major concerns there. So we've got a slope of 9. For the other one, move that x over. So 9y equals now minus x plus 23. We'll divide by our 9. And y equals now minus 1/9 x plus 23 over 9. My slope is minus 1/9. Okay, what do you think these are going to be? Well, if we look at them first off, they have to meet the two criteria. Are these opposite of signs from each other? Is one positive and one negative? Yes. Okay, so that's your first step. Make sure they're opposite in signs. They are. And are they reciprocals? Meaning if I flip one over, do I get the other one? Yes, you do. So these would be perpendicular. So those would be perpendicular because if you flip them over and change the sign, you get the other one. I want to do one more that's neither. And I want to show you why this one is neither. Let's see. How about 4x plus 10y equals 3. Okay, now these are going to be neither. I'm going to show you why they're going to be neither at the end. So let's go ahead now and take each one, solve it for y, get our slope. Now remember, for them to be perpendicular, what do they have to have? Negative or opposite signs, reciprocal slopes. One has to be positive, one has to be negative, and they need to be reciprocals. So let's go ahead and take our first equation, move that 5x over. So 2y equals now a minus 5x plus 10. Divide by our 2. And y equals now negative 5 halves x plus 5. So my slope is negative 5 halves. That 2x over, or sorry, that 5x over, divide and reduce, and that gives you your first slope. We've got to do the same thing for the one on the right. So we're going to move our 4x over again. 10y equals minus 4x plus 3. We're going to divide by our 10. And we've got to reduce these down. You must reduce them down. We're going to reduce them down. And 4/10, well, that reduces down to, and it's a negative, so that reduces down to 2/5 x, and it's negative there. 3/10 does not. My slope is minus 2/5. Okay, now, a lot of times students make a mistake here. These are not perpendicular. Why not? For it to be perpendicular, it has to meet these two criteria. It has to be both. They have to be opposites in signs, and they're reciprocals. Well, they are reciprocals, right? If I flip this fraction over, I get this fraction, right? But what do you notice about the signs? The signs are the same. They need to be opposite. They need to be different. So these would be neither. And why are they neither? They're neither because the signs are the same. So that's why they would be neither, because the signs are the same. If they were opposite in signs, then they would be perpendicular. But in this case, they are not. Now let's look at some of the questions from our homework. Quickly here, just how to set some of these up. We've covered everything, but I just want to make sure that we know how to do these applications. They're going to be very easy to work through, but I'm going to help you set up question number 3. So on your homework 3.3, you're going to look at question number 3. It says the data regarding the amount spent by the government department is represented by the following graph. Find the slope of the line using any of the 2 points shown on the line. The slope is equal to the yearly change, and is the slope equal to the yearly change in the amount spent? Okay, so I want to make sure that we can see our points here and make sure we know what our ordered pairs are. Remember, this is your X and this is your Y. Now, we need to come up with ordered pairs. I'm going to make sure we see how this graph works so we can get our ordered pairs here. Look at your y-axis first. Okay, your y-axis, that's 7.2. Right? Now, if we did 7.3, 7.4, 7.5, see, it wouldn't go up to 8. So these are going up in 0.2 increments. So that's 7.2. The next one is 7.4. The next one is 7.6. And the next one is 7.8. Right? They're going up by 0.2 each time. So if I was trying to find this point right here as an ordered pair, what would it be? As an ordered pair, remember your X goes first. So the X in this ordered pair would correspond to what? If I look at my X value, it looks like that X is 19 what? 1998, right? So that's going to be 1998. And then what's the Y value? How many billions are spent? Well, it looks like it's going to be 7.6. Now we need 2 points, so this one's going to be easy to get right here. So let's get that one. What would that one be as an ordered pair? That one as an ordered pair would be at 2,000. And what's its value? Well, if that's 8.8, the next one up is 9. So we want to find the slope. So we've got our 2 points. 1998, comma 7.6. And we've got 2,000, comma 9. I want you to use m equals y1 minus y2, or x1 minus x2. Okay, so what we had to do was we looked at our picture. Now, look at your picture. Of course, you're looking at government spending, right? We know government spending always goes up. Look at your graph. Your graph has a positive slope, so it's going up. That makes sense. You know, government spending always goes up. Now, we want to figure out what is the change per year. How much more are we spending every year? So we went through and we found our ordered pairs. So we've got 1998, and then when we read it off the table, it looks like it's about 7.6. Then we've got the 2,000, because that one's kind of in between, so I wouldn't recommend picking this one. I would just pick this one up here at the year 2000. And if we read it, it looks like it's at about 9. Okay, so that's 2,000, comma 9. Use that with your slope formula to come up now with the change per year. How many more billion are you spending every year? So that's what I want you to do on that. Is just use these 2 ordered pairs with our slope formula. That's what they're wanting you to find. Let's talk about some of the other applications. Question 12 is going to be almost identical, right? I'll help you set up the points again. So for question 12, we're doing the same thing. Numbers are different, points are different. Okay, so let's try to find our 2 points. Doesn't matter which 2 we pick. Looks like they're both in between. So this point right here, as an ordered pair, would be, there's 7.2, 7.4, 7.6, 7.8. It looks like it's right in between them. So I would say that's 1998, comma, about 7.7. It goes right in between there. And let's pick another one up here. Doesn't matter which one we pick. Well, let's just use this point right here. As an ordered pair, it looks like this point is the year 2000. And it looks like there's 8.8 and 9. It's in between. So let's say 8.9. Okay, and then you're going to use those 2 points. And I just want to make sure I read them off the graph for you because it's easy to look at the graph wrong. And I want to make sure we see where the points came from. So there's my points. And I want you to use m equals y1 minus y2 over x1 minus x2. So it's going to give you a different answer there, but you're going to use that graph instead. And I picked my ordered pairs. I wanted to make sure we see how the ordered pairs work. So you could finish that one from there. Now, what about 13? 13 is the pitch. And remember, the pitch, what does the pitch mean? Pitch means the slope. And that is the rise over the run. So if I take my figure and I plug in my values, we've got 20 for the x value, and we've got 5 for the y value. You should know what to do. Slope is rise over run. So what would I do? I've got my rise. There's my run. I can use that to calculate the pitch or the slope. So you've got everything filled in for you. Just use that to get your slope. Same thing for number 14. On a hiking hill, the trail goes up 60 feet over a distance of 122 feet. We want to find the grade. What's the grade again? Grade again is the slope. What's the slope? Rise over the run. So you're going up 60 over 122. Right? So there's your formula. Right? Just use that. You've got 60 over 122. Break it down from there. Not going to finish it. You should know what to do. You're wanting the grade, which is the slope. You've got it labeled as you're going up. That's your rise. Over, which is the run. Put them together. Find your slope. Okay, so that should now finish up the lecture for today. And just so we know what we've covered in our homework, we covered actually quite a bit. You'll find it's pretty easy and quick to go through though. It's going to be a lot quicker than the one out of chapter 2. So what's our homework now? Well, our homework, we did 3.1. You should be able to do them all. 3.2, should be able to do them all. 3.3, should be able to do them all. I think, though, again, when you start working through the homework, you're going to find that it's much, much easier than what we did in chapter 2. If you didn't turn your homework in last week, make sure I get that today. If you absolutely don't have it done, you can turn it in next week, but you don't want to get too far behind. That's the main thing, is do not get too far behind. Also, if you haven't taken your exam, you can take that today or later on this week. It's in my mailbox. Just ask the front office for it. Just tell them you want to take your exam. They'll get it out of my mailbox, and they'll put you in the quiet room, and you can take that exam. Okay? So a lot of you have taken it. Some of you haven't. If you've got your homework finished, turn it in. If you want to turn it in next week, you can do that too. I just want to make sure you do as well as you can on the homework, but just don't fall too far behind. Okay? All right. I will see everyone then next week.